So chapter 10, section 3 has a title of Using Permutations and Combinations. Golly, I wonder what those things are. Well, there are a couple more tools that we're going to have to help us count on certain problems. So we're going to begin this section by defining what a permutation is mathematically. And until we look at permutations in the context of counting problems, it won't make any sense how this is going to help us, but eventually it will. So just hang with us for a few minutes, and we'll eventually get to how this is going to be used for us. So part A, permutation. Hey, it's not easy to write on this thing, so yeah, that's not the prettiest writing of permutation in the world, but you'll just have to be okay with it, I hope. Okay, let's talk about some notation. This is a permutation, P parentheses N comma R. This reads a permutation of N things taken R at a time. Sometimes you also see the the notation written this way. This means the same thing. That also means a permutation of N things taken R at a time. Either way, the definition of a permutation mathematically goes like this. It's N factorial over the quantity N minus R factorial. So, let's say that we had something like this, a permutation of 8 things taken 5 at a time. How could I figure out what that's equal to? Well, my N is 8 and my R is 5. So substituting into the formula would give me 8 factorial over the quantity 8 minus 5 factorial, which would be 8 factorial over 3 factorial, which would be, what's 8 factorial equal to? Do you guys remember? How do I find it? Well, that's true. There you go. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial would be 3 times 2 times 1. Now right here, this very next thing that I'm going to do is really going to give you a good idea behind what a permutation is. Watch this. 3 times 2 times 1 is going to cancel with 3 times 2 times 1. And an a permutation of 8 things taken 5 at a time is going to end up being 8 times 7 times 6 times 5 times 4. In other words, it's the first 5 factors of 8 factorial, isn't it? That's what it ends up being at the end of the day. If I would have had an 8 permutation 2, then it would have been the first 2 factors of 8 factorial. If it would have been an 8 permutation 6, it would have been the first 6 factors of 8 factorial. By the way, has somebody multiplied this out?
6,720.
Okay. There you go, 6,720. Now, what kind of problem, what kind of counting problem would I need to do this with? Well, let's go chew on that for a minute. So for a moment here, we're not really taking notes, we're just chewing on some things. I want to recall yesterday. Yesterday we had Karina, Daniel, and Donna, and for Donna I'll call her in so it doesn't compete with Daniel. Okay. Karina, Donna, Daniel, and Donna. And I asked, how many different ways could you guys line them up? And you guys ended up saying it was 6. And at the end of the day, you said it was 3 people could go in the first slot, 2 could go in the second slot, 1 could go in the third slot. 3 factorial. Then we generalized that. I asked you if there were 5 people, how would you figure out how many ways 5 people could line up? And you decided that'd be 5 factorial, right? Okay, what if we change the question? What if I said I had 8 people, and I asked the question, how many ways could I choose 5 of the 8 people, and how many different ways could I line them up? If I'm choosing 5 out of 8, how many different ways could I end up with 5 people lined up out of 8 people that I'm choosing from? Well, I'm only choosing 5, so now I only got 5 slots, right? How many ways could the first slot be filled in? 8. How many ways could the second slot be filled in? 7, and then 6, and then 5, and then 4. Do you see that here I have a permutation of 8 things taken 5 at a time? So on that kind of problem is when we're going to be able to use a permutation. Now I'm going to formalize that a little bit more later. You don't need to write that down into your notes right now or anything. I'm just trying to get you set up for that a little later on. But that's the notion. That's how we're going to end up with some permutations. You would think that if your calculator could do a factorial, you would think surely it'd be able to do a permutation too, wouldn't it? Okay, so you're looking for a function on your calculator that probably looks like, you're probably looking for a button on your calculator that's probably going to look like this notation here. If you found your factorial on your calculator yesterday, this is going to be found somewhere near your factorial button, most likely. If you've got a graphing calculator, a TI, it's going to be in that math menu, Daniel, that I showed you yesterday. Karina, yours is going to be in that PRB menu. So find the button, and most calculators is going to work this way. You're going to punch the 8 in first, then the function, NPR, then the 5. Make sure you can punch that in and get 6,720. And I'll pause for a minute and let you do that. James, is that success? Is that what means?
Yes, it was a
Dustin, are you having any luck?
Yeah.
Amy.
Yep.
Okay, Anna. Head shakes or voices, give me something. Mr. Black, you're ugly, whatever. Okay, Cairo.
Yeah.
And main campus. All right. So, when are we going to use permutations? How are we going to know to use a permutation? Now, here's the key right here. You're going to use permutations when, there are 2 things that are going to happen. Number 1, repetition is not allowed And number 2, order matters. So yesterday we talked about the difference of a problem when order matters and when order does not matter. What we said is if you switch any 2 of the possibilities, if you get something different, then order matters. If you switch them and we don't get anything different, order doesn't matter. Some examples of what we talked about yesterday is if we were picking 2 people for president and vice president. If we pick Dave then Evelyn, Dave's the president, Evelyn's the vice, that's different than Evelyn then Dave. Because then Evelyn's president and Dave's vice president. In that case, order would matter. An example of order not mattering would be if we're picking 2 people to serve on a committee, then David, Evelyn, and Evelyn, David are the same committee. So in that case, order would not matter. We're going to use permutations when order matters. Okay, so we're going to ask these 2 questions a lot moving forward in this chapter. We're going to ask a lot of times, is repetition allowed and does order matter? So we might as well get ready for that. Let's look at a couple problems related to permutations. So let's go to example 3 in your textbook. It is on page 546. Let's change it up, do a little red for a minute. Okay, here's what it says. How many non-repeating 3-digit numbers can be written using only the digits 3, 4, 5, 6, 7, and 8? So it's a how many question, so it's counting. And when it's counting moving forward, we're going to go to these 2 questions very often, early and often. So number 1, is repetition allowed? Class, is repetition allowed on this problem?
No.
What's the key word? It's non-repeating. So no, it's not allowed. So the second question is, does order matter? Okay, now, if you don't know, then here's how you see if order matters. Pick one possible result. Well, 345 would be one possible result, right? 345. Now, if I switched any 2 of those, if I turned the 4 and the 3 around, and I said 435, is that the same result or is that a different result? It's a different result. So does order matter? Yes, it does. So order does matter. So I can use a permutation to do this problem because my 2 conditions are met. Repetition is not allowed and order matters. Okay, so I got a permutation. How many digits am I picking from? 6. I'm picking from 3, 4, 5, 6, 7, or 8. And how many am I picking? 3. So I can find this by doing a permutation of 6 things, 3 at a time. So make sure you can punch that in on your calculator and get 120. Okay, everybody golden there? La da 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 da. Mr. Black, that wasn't that bad. I kind of like this stuff. Okay, I'm going to pause our video and I'm going to put up 2 problems. I want you to write them into your notes. And on one of these 2 problems, we're going to be able to use a permutation. And on the other problem, we're not going to be able to use a permutation. So, here we go. Maybe I'll try to do this the pretty way. I'll try to get fancy here. Isn't that what I do? I thought that's what I did. Class, I thought that's what I did. It's not what I do. That's not what I do either. I know that's what I do, isn't it? Isn't that what I do? That's not it. It's that one, doggone it. I know it is. There we go. There we go. Okay, see if this is going to be big enough for you to read. Oops. I might be able to make it bigger in a minute. Let's consider that question I asked you yesterday. How many ways can 16 teams, not gyms, teams, finish 1 through 4 in a tournament? So lots of basketball tournaments are 16-team tournaments, right? Just about every Christmas tournament is 16 teams. Okay, so there's one question we're going to consider. Okay, now let's go down here and let's do the same thing again. There we go. Here's the second question. How many ways can a committee of 4 be chosen from a club of 16 members? I guess I never did stop the video. Anyway. Okay. So the first thing I want you to do is I want you to think about these two questions and ask yourself, would the answer to these two questions be the same number, first of all? No. You don't think so, Daniel? Let some other people chew on that for a moment. Daniel, why do you think they wouldn't be the same? Yeah, I kind of let the cat out of the bag earlier, didn't I? When I said you're only going to be able to use a permutation on one of them. Okay. So, whenever the question starts with how many, we've kind of started to think this way. The first question is repetition allowed? So let's take the first problem. How many ways can 16 teams finish 1 through 4 in a tournament? So is repetition allowed on that problem, ladies and gentlemen?
No.
No, why not?
Because a team can't be
Because the same team can't finish in 2 different spots.
That's right. Shawnee College can't finish both first and second in the same term, right? So repetition is not allowed. How about the bottom one? How many ways can a committee of 4 be chosen from a group of 16? Is repetition allowed there? Daniel's flip-flopping on me.
it is.
It is allowed? Repetition is allowed? So if repetition is allowed, that means, Daniel, that if you're in the club, we would let you serve 2 spots on the committee. Are we going to let you serve 2 slots on the committee? No, probably not, right? So repetition's not allowed there either. So in that sense, these two problems are alike. Now, let's go back to the first question. Let's see if a permutation can be used on the first one, class. Does order matter on the first one? If you don't know, then list a result down and then flip-flop 2 of them, see if you get something different. So let's see. I'm trying to think. One of the big Christmas tournaments around here is the Cesar Valier High School tournament. So Goreville plays in that. Some of the other local teams play in it. It kind of makes me sick because Waltonville and Woodlawn play in it, and they were in my conference when I played growing up, and I hate those guys. Even now that I'm almost 50, they're booger eaters, and we hate all of them. Okay, so anyway. Okay, so let's say that in the tournament, Cesar Valier finished first, Goreville finished second, Woodlawn finished third, and I forget who else is in that tournament. Christopher finished fourth. Is that the same result as if I switch any two of them? Say I go Goreville, Cesar, Woodlawn, Christopher. Are these two things the same thing or not? They're not the same thing, so order does matter, doesn't it? Okay, so in this problem, to figure its answer, we could do a permutation of 16 things taken 4 at a time.
And if we was to put a permutation of 14, 16 at a time, would it be a different answer?
You can't take a permutation of 4 things 16 at a time, and because you can't pick 16 teams out of 4. You can pick 4 teams out of 16, though, can't you? Yeah. So if you go 16, permutation 4, my calculator is giving me 43,680. Now, let's consider the second question. We've already said that repetition is not allowed. Now let's see if order matters. So here's our committee: Michaela, Taylor, Caitlin, Holden. Is that the same committee as Taylor, Michaela, Caitlin, Holden?
Yes.
It is the same committee, so order doesn't matter. So I cannot use a permutation on the second one. So the question is, what do I do when order does not matter? So we're going to chase that rabbit next. So we'll come back to this problem and finish it. We just don't have the tools to finish it yet. Okay, what we're going to need to finish it is a critter called a combination. So let's define a combination mathematically first. A combination can be written 2 ways. You can write C parentheses N comma R, and that reads a combination of N things taken R at a time. Or you can do N and then C and then R, which reads the same way, a combination of N things taken R at a time. The formula for a combination goes like this. It changes a little bit from a permutation. It goes N factorial over R factorial times N minus R factorial. So in a combination, we have an extra factor in the denominator of the R factorial that we didn't have in the permutation. That is a yawn. I think it came from James. Everybody say stop it, James, on the count of 3. Ready? 1, 2, 3. Stop it, James. James, what do you have to say for yourself, sir?
Sorry.
There you go. So if we had an 8 I'm listening.
I have a question. The permutation that we just did,
Yes.
real quick, where you had NPR and you put it in the calculator.
Yes.
And then when you broke it down and it was the N, the permutation, the exclamation mark, whichever, over n minus r. Will we ever break it down like that on a test, or
Nope.
is that basically saying what NPR does?
That's saying what the NPR does. I just showed it to you so you'd have some context for what your calculator's doing, but moving forward, we'll do them on our calculator.
Okay.
And I'm showing you this, but here in a moment, we're going to do it on our calculator.
Mr. Black,
Sir?
so the bigger number always goes before the, like the.
That's right, because you're taking this many out of this. So the bigger number has to go first. You can't take something bigger out of something smaller. Okay, so how's this going to flesh out? Well, we'd have 8 factorial for our n factorial. R factorial would be 5 factorial. And n minus r would be 8 minus 5, which is going to give me 3 factorial. Let's see what that's going to give me. Well, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is going to give me 5 times 4 times 3 times 2 times 1. And 3 factorial is going to give me 3 times 2 times 1. So 5 times 4 times 3 times 2 times 1 would cancel with 5 times 4 times 3 times 2 times 1. 3 times 2 would make 6, which would then cancel with this 6. It looks to me like an 8 combination 5 is equal to 56. Now, why don't you see if you can find the combination on your calculator and see if you can also get 56 that way. When you get it, give me a thumbs up so that I know that you got it.
Will we ever have to do it like the long way, like you did?
Class, will we ever have to do it the long way? Nope. I just wouldn't be a very good teacher if I didn't show you the long way. Hey, Dustin, I never got a thumbs up from you.
Right, hold on.
So when do we use combinations? Well, you can probably guess now. So let's write this into our notes. Use combinations when, I really should say use a combination, but you get the idea. 2 conditions are met. Number 1, repetition is not allowed. And 2, order does not matter. Repetition is not allowed. Order does not matter. Mr. Black, shut up. You're not a good singer. Well, I remember that one time when I was the detention teacher at Scott City, both junior high and high school at the same time, and middle school. So I had this 6th grade little kid come into my class for detention, and I sang some little song or something, and the 6th grader looked at me and said, "Who sang that song?" And I said, "Whoever it was." He said, "Let him sing it." That's not very nice. Golly, 6th grader. 6th graders are tough, man. Okay, well, Mr. Black, what you looking at here? Well, let's go to example 7 and example 8 next. So we'll go to example 7, obviously, first. Somebody got a page number for us? 548? Okay, here goes. Find the number of different subsets of size 2 in the set A, B, C, D. Then it says list them to check the answer. Okay, now you're not going to have to list them on your homework, but we'll do it here just to prove the point. Okay, so I got 4 things here, and I'm making subsets. Now, I haven't really told you what a subset is. A subset is any combination, oh, I used the wrong word there, because now you're going to know. But anyway, any pairing of these 2 letters. And the order in which they're paired would not matter. Okay, so here's the way I'm thinking now. First of all, is repetition allowed? Is AA a subset? And the answer to that is no. 2 of them are going to be paired together to make a subset. Okay, so repetition is not allowed. Now, B, does order matter? I just told you that it didn't. AB is the same subset as BA. Okay, so since those 2 conditions are met, I can use a combination. What just happened?